Okay, so question number 1, a 4-kilogram object moving across a frictionless surface with a constant velocity of 2 meters per second. The words constant velocity are important there. Which one of the following horizontal forces is necessary to maintain the state of motion? Excellent. You guys chose majority.
0. Oh, 2 wrong. Oh, no.
Oh yes, friction. I was confused. My mistake. Frictionless surface, 0. Excellent. Yeah, everybody got that right. Couple people chose to go 4 times 2. That's a mass times the velocity. That is nothing that you know about yet. Mass times velocity doesn't mean anything to you. Number 2, what is the value of the friction force? A 20-kilogram box is gliding towards the right across the floor with an acceleration of 1 meter per second squared. Right? F equals mass times acceleration, so it should be 20 times 1. It should be minus 20. What did I have?
20 is wrong.
Oh, 20 is correct. According to this, the correct answer, 20 is correct. How many put minus 20? Give yourself a check mark. If the force is acting upon an object of balance, then the object, correct answer is C, must not be accelerating. 0 net force means no acceleration. And I know that is in your handout somewhere. Put a star beside that one, right? F net equals 0, right? The force acting upon an object is balanced. If the net force is 0, therefore the acceleration is 0, which could mean moving at a constant speed, or it could mean at rest. A 20-kilogram object will encounter 50 Newton frictional force when pushed across a horizontal surface. With what force must you push the object in order to maintain this constant velocity? And that correct answer is 50. You must have enough to balance friction, and it looked like most people got that. But there's friction, right? You have to balance friction. Little Billy has a mass of 25 kilograms. How much force must be applied to Little Billy in order to lift him upward with a constant velocity of 2 meters per second? Explain your answer or show your calculation. Now, does the 2 meters per second matter? No, not really. The weight force down, as Peyton pointed out, is 25 times 9.8, which I think is 245, am I right? So if there's 245 newtons of gravity pulling down, how much do you have to pull up to move him at a constant velocity? 245.
I didn't even know what that thing meant.
245 newtons. Now, I will certainly say that I haven't actually specifically showed you questions like that. If you got that one, it's because you understand everything and you can apply it to a new situation. So that's good. Number 6, an automobile has a mass of 1,600 kilograms. What force is required to give an acceleration of 1.2 meters per second squared if there are frictional forces totaling 200 newtons? This, I think, is actually a 2-mark question, a 2-parter, right?
Not really.
F net is equal to MA. 1,600 times 1.2.
1920.
How much? 1920? Okay, so the net force is 1920. Then you would write F net is equal to FA plus FF. 1920, we're solving for the applied force. The friction force is minus 200, goes to the other side. 1920 plus 200. Did you get that one, Hannah?
200. I sure did. I got it right.
That is exactly like the last example that I left you with on Wednesday, I believe, right? Time to look back again at that. Trust me, Dana, you're going to see that question again. You'll get it right the next time. Body of mass 15 kilograms rests on a frictionless surface and has a 30 Newton applied to it. What acceleration is produced? I think this one's pretty easy, is it not? How did we do on this? I hope. Yeah, everybody got it, right? Is it not just 30 equals 15a, right? 30 divided by 15 or 2. Looks like everybody got that one. Then answered it. What will its velocity be at the end of 8 seconds? What were we given in 7 here? We were given the acceleration. So, given the acceleration, delta V over delta T. What was it, 2?
Yeah.
That, delta 6. Delta V equals 16. Because the initial velocity is 0, we really should show this, right? The final velocity is 16. Remember, the delta V and the VF are only the same number when VI is equal to 0. How'd we do there? Yay. Number 10, the diagram below shows forces acting on cars that are moving to the left. The size of the force is denoted by the size of the arrow. So in other words, the bigger the force, the bigger the arrow. Which cars would be undergoing non-uniform motion? Which ones would be accelerating? And the correct answer is D, all of them. There's, in all cases, unbalanced forces. These ones are balanced. This one's much bigger than this. Which way is the net force? That way. Which way is the net force here? That way. Which way is the net force here? Oddly enough, upwards.
Yeah, I don't get that one.
Hey, it is what it is, man. Can't argue with arrows.
Yeah, you could.
All of them have a net force, Jake. Jake, leave her alone so she can concentrate. Square your shoulders, please, to the screen. Thank you.
What, do I like corrupt people?
No. Number 11, a vintage car can accelerate in third gear from 80 to 104 seconds. The acceleration measured in meters per second is about.
Why is it 5.1?
Well, we're first of all going to have to go 100 minus 80, which is 20.
Yeah.
And that's kilometers per hour. And then we're going to have to divide that by 3.6. And I'm going to steal my calculator back, Steve.
Yeah.
20 divided by 3.6 is 5.55 roughly, and that is my velocity, right? That's my delta V. So now you'd go something like delta V equals, no, hang on.
Yes.
You would go
5 over.
A equals delta V over delta T. 5.55 divided by 4 seconds. It's around 1.4. A.
Alright, I got it. Convert it.
Probably, your probably common mistake would be forgetting that conversion, right? So you got it right. It says is about. So which one of those is closest to 1.38?
1.38.
Which one of these 4 multiple choice answers is closest to 1.38? Now, how many people agree that number 12 is crazy hard?
It's ridiculous.
Notice that my hand is maintaining up.
Is that like given to someone?
This is probably beyond your abilities at the time. I will expect you to be able to do this by the end, though. Let's give it a whirl. The catapult launching aid system on an aircraft carrier is a mechanical device that accelerates jet fighters across the deck up to takeoff speed in quite a short distance. It's really just a big elastic band that helps the aircraft get up to speed so it can take off on a really short runway on an aircraft carrier. A jet has a mass of 1,700 kilos and needs to achieve a takeoff speed greater than 225 kilometers an hour. This is achieved with a catapult system capable of pulling the jet with a force of 50,000 newtons. With these requirements, the minimum distance along the deck needed for a successful takeoff would be about, in other words, how long is the aircraft carrier need to be?
Too hard.
What do we got here? We got a mass. We've got an applied force. of about 50,000, and we need a change in velocity of 225. Do you get the feeling that we should convert that 225?
Yes.
Because this is in meters, right? And this is in, well, this is mass. We know that the acceleration is going to be meters per second squared. So let's first step go 225 divided by 3.6. By the way, if this was a test question, it would not be multiple choice.
It should be.
No, that's not right. 62.5.
Actually,
Okay. So the delta V must be 62.5, right? I know my mass. Do I know my acceleration? No, but I could figure that out, couldn't I, right? Like, what I really need to do is come up with distance, right?
well, how?
I'm going to need V bar equals distance over time, eventually. Do I have my time yet?
No.
Do I have my average velocity?
No.
Could I solve for average velocity yet?
Yes.
Yes, I could, because I know the initial 0, I know the final.
2.5 divided by 2.
V bar equals VI plus VF all over 2. 0 plus 62.5 over 2 is 31.25, right?
Yep.
Okay, so now I have my V bar. Now I have to solve for my
Time.
time. How am I going to get time?
Finding the acceleration.
Acceleration is delta V over delta T. If I could get the acceleration, then I could get the time. How am I going to get the acceleration?
F equals ma.
F equals ma. 50,000. 1,700. Required acceleration of 50,000 divided by 1,700. 29.4. Right? Ready? Yeah, they didn't mention any friction. Would the friction be enough to worry about here?
No.
Like 50,000 newtons of pulling force, how much friction is there going to be?
1 Newton.
Negligible. Right? If it doesn't say so, then you can basically ignore it. Okay, so now I'm going to go A equals delta V over delta T. Notice how I'm writing formulas here. 29.4 is my 31.25 all over delta T. Oh, this T is going to be a real short number, isn't it? 31.25 divided by 29.4 is going to be a little over 1.06 seconds. And now, is that right? Oh, I did. I did. So this would be 62.5, right? Thank you. That did seem a little short.
What would you then 62.5 divided by 29.4?
2.13. Now you go V bar equals d over t. The average, 31.25, D, 2.13. Am I good so far? Oh, what did I do? 66 meters, approximately. So I get 66.4. Which one of those? There, B, right? Now, how much would that be? I'll move this one up here a bit so you can...
80,000.
I sort of got things out of order here a bit, don't I?
A lot of marks.
How many marks? 1, 2, 3, 4, 5.
So, how did you get to 403 again?
62.5 divided by 29.4.